We are going to start with the next one. Next one means the next chapter, that is solution. Right? So we will start with solution. Okay, this no need of writing anything specific. Okay, what you are going to write is that just the topics we are going to cover, because yesterday because of the weather I could not make the photocopies ready. Okay, so next day whenever we will come, we will get the photocopies of the study map only. Okay, of the solution chapter. So no issues of that. Today I will send it in the soft copy, in the form of soft copy. I will send it so you can see it from there also. Okay, so I'm going to start with solution. Just to write down the topics, that's all. Okay, solutions. But first of all, what do you understand by a solution? Tell me. What do you understand by a solution? Tell me. I don't know what is solution. I don't know what is solution. So how can I say that what is solute and solvent? I don't know what is solution. Okay, simply I don't know what is solution. How do I know what is solute and solvent? No, no. I asked you what do you understand? What do you understand by solution? Understand. Understand means what do you think? What is solution is? Tell me. Simple thing. I didn't ask anything tough. I always give emphasis on the concept, and that is what is the most important thing. So, what is a solution for you? Okay, give me an example. Fine. Give me an example. Sugar in water. Okay. Why is it a solution? It gets dissolved in water. So, see, it's not that you don't know it, you know it very well. Okay, what is solution? You know, in that sugar and water, if I add salt also, is it still remaining solution? In that sugar and water, I am adding a little bit of salt also. Is it remaining solution? Yes, still it remains solution. But if I add sand and sand and sugar, will it be a solution? No. Why not? Why not? Why not? We are mixing there also, we are mixing here also. Why not? See, two things you must understand. One is that solution means what? It's a uniform mixture. Must be a uniform mixture. Means homogeneous mixture. You have heard about this word, homogeneous mixture or uniform mixture. Okay, where you cannot identify that this is sugar, this is water, or this is salt, this is water. You cannot distinguish between them. Clear? It's a homogeneous mixture of two, at least two, or more than two components. At least two or more than two components. Two or more components. Clear? It's a homogeneous mixture of two or more than two components. That is what is solution is. Okay. As I told, if you talk about sugar and water, it is a two component system. If it is sugar, salt and water, it is a three component system. It can be more number of components also. Okay. But at least there should be what? At least there should be two components. And it must be a homogeneous mixture. Okay. If I add sand in water, it is certainly not going to form the solution. Why not? Because they are not going to form the homogeneous solution. You know, sand is separate, water is separate. Yes, that's not a homogeneous solution. First concept. Second concept. Whenever I will ask you, I asked you already that give me an example. You will give the example something which is liquid, right? So pre-minded concept is there that solution means liquid. No. Solution can be solid also. Solution can be gas also. The air in which we are staying is also a solution, because it's also a uniform mixture of many components. Clear? Oxygen is there, nitrogen is there, carbon dioxide is there. Now you cannot say that oxygen, this is nitrogen or this is carbon dioxide. You cannot say that. It's a uniform mixture of two or more than two components. Clear? Okay. So it can be a mixture of two or more than two components. If two components are there, we call it binary solution. We call it binary solution by 2. If three components are there, we call it ternary solution. Ternary, okay? Not dry, we call it ternary solution. If 4 components are there, we call it ternary solution, and so on, and so on. Okay. In our syllabus, only the binary solution is there. Clear? So we are going to deal with the binary solution only. That means the solution with 2 components. Clear? Now these 2 components you told, already you said that these 2 components are, one of them is called solute and one of them is called solvent. Now which one is solute, which one is solvent? Which one is solute, which one is solvent? Tell me, which one is solute, which one is solvent? In water and sugar, suppose, which one is solute, which one is solvent? Sugar is solute and water is solvent. Why? Or sugar dissolves the water. Which is solute, which is solvent? You told okay, sugar is solute. इधर यहाँ से भी कोई बोल सकते हो भाई आप लोग भी online में जो है. Sugar is solute and water is solvent. Why? Why sugar is called solute and why water is called solvent? Out of these 2 components, whichever is more in amount, that is called solute. Solvent, sorry. And the one which is lesser in amount is called solute. Clear? The one which is lesser in amount is called solute, and the one which is more in amount is called solvent. That is one point. And the last point which you must know about the basic concept of solvent, that the phase or the state of the solution is the state of the solvent. For example, sugar and water you told. What is the solvent? Water. What is the state of water? Liquid. State of water? Liquid. Right? So what is the state of the solution? Liquid. So whatever is the state of the solvent, that will be the state of the solution. Solution will take that particular state. Clear? Now depending on the states of the solution, the solution can be further classified into 3 types. Right? One we call solid solution. What is solid solution? Means the solution will be solid in nature, solid in state. When the solution will be solid? When the solvent is solid. When the solvent is solid, then only the solution will be solid. So there are 3 types of solid solution possible. One, solid in solid. Solid dissolved in solid. Yes? Okay. Another one, liquid in solid. Another one, gas in solid. These are 3 types of solid solution possible. Can you give me an example of solid in solid? Solid in solid, the solution is there. Solid in solid. Can you give me an example? Okay, the one I am wearing over here, what is this? This is not gold. This is not pure gold. The ornament golds are not pure golds, right? What is mixed in it? Copper. Mainly copper is mixed in it. It is 22 karat gold. Okay, so that's not ornament gold and not pure gold. This is mixed with copper. Can you say that this much is copper, this much is gold? You cannot say, right? So here copper and gold is uniformly mixed. Uniformly mixed or not? Yes. So obviously copper is the solute and gold is the solvent in this particular case. Clear? Okay. But it is uniformly mixed. Solid in solid. Understood that? So that type of solution are called what? Solid solution. That is one of the example of solid solution. What is this called? This is called an alloy. It's nothing, any alloy. I am just taking an example. Any alloy we know is an example of what? Is an example of solid in solid. Clear? Can you give me an example of liquid in solid? But liquid in solid. Just think of that. Liquid and solid. Liquid in solid. A solution which is solid in state, but whose solute is liquid. Liquid in solid. बताओ कुछ दिमाग में आ रहा है? Anything coming in mind? No? Okay. You have heard about this, so it's nothing new. It's not striking at this moment. That doesn't matter. That's absolutely fine. If I talk about this, what is this? What is this? You tell me. What is this? Zinc amalgam. We call it amalgam, right? Yes. Zinc amalgam means what? Zinc in mercury or mercury in zinc. Mercury and zinc. Amalgam means what? Mercury is mixed with the other metal. It can be zinc amalgam, it can be sodium amalgam, whatever it is. Okay, a metal is mixed with mercury. What is the state of mercury? Liquid. So liquid is dissolved in solid. The other metal is solid. Only mercury is liquid. Mercury is dissolved in the other metal, so that's also an alloy, a special type of alloy, right? What is that alloy known as? This is called amalgam, right? What is this called? This is called amalgam, whether it is zinc amalgam or sodium amalgam or copper amalgam, whatever it is, okay? So amalgam is an example. I think you have heard about this. This is nothing new for you. This term is also not new for you. This amalgam is what? Amalgam is an example of liquid in solid. Yes? Okay. Tell me an example of gas in solid. Gas in solid. बताओ. Just think and tell. Gas in solid. कुछ भी आप just anything you think. Every day we are using it. It's not that we are not using it. Every day. Some gas is dissolved in some solid. पता? नहीं, Coca-Cola solid का है. This is not solid, huh? What is that? नहीं. कहाँ पे gas dissolved है solid में कहाँ पे? Bread. है bread? Cake. Yes? Sponge. Yes? The foam we are sitting or we are sleeping. Yes? What is there? The gas is there or not? Gas is there dissolved in solid or not? Yes? These are all the examples of the solution of gas in solid. Did you get it? Understood that? Yes or not? Bread में क्या होता है? Carbon dioxide होता है solid में, है ना? Cake में भी वही होता है. Yes or not? In these cases, in case of sponge or foam, the air is there, a lot of gas is there. Gas in solid. Same way, liquid solution, the next type, liquid solution, that means the state of the solution will be liquid, can be also further classified into three types. Huh? What are these? Solid and liquid. Yes? Tell me an example of solid and liquid. So many we know, right? अभी बताया sugar and water. Okay, fine. Solid and liquid. Fine. That is actually generally we think that is the solution. No, there are so many types of solution. Okay. Then liquid in liquid. Tell me an example of liquid in liquid. That also you can tell. Huh? It must be a miscible liquid. Two miscible liquids, like water and alcohol. Water and alcohol. Water and oil नहीं हो सकता है, because they are not miscible. They are not going to form that homogeneous mixture. Okay. Water and alcohol is an example of what? Water and alcohol is an example of liquid in liquid solution. Yes. Then gas in liquid. Yes. What Srija was telling. Gas in liquid. That is the cold drinks, Coke, Pepsi, etc. The gas is dissolved in the liquid, right? Gas is dissolved in the liquid. Yes? Yes or no? Fine. Then, what is the next type of solution? Gaseous solution. Gaseous solution. Gaseous solution means now the solvent is gas. So this can be also of three types. This can be also of three types. What are the three types? Solid in gas. Tell me an example of solid in gas. अभी आया बाहर से बताओ. Solid in gas क्या है? What is that? Just now you have come from outside and you have come through it also. Solid in gas. The smoke. पता है smoke में solid particles होता है. बहुत सारे solid particles होता है. If you stand in smoke mode for 5 to 10 minutes, you will find that your face is full of the particles. है ना? Black particles are there. So smoke में क्या आता है? The solid particles are all dissolved in the gas. Whatever smoke is coming out from the chimneys of the factories and all, these are all the solution of solid in gas. Okay? Then liquid in gas. Tell me, liquid in gas. Liquid in gas. Tell. अभी कहाँ जाने से मिलेगा liquid in gas? I'm giving you the hint also. Where to go to get the liquid in gas solution? चलो दार्जिलिंग में मिल जाएगा. What is that? Fog, mist. पता है liquid droplets, if you go through the fog, go through the mist, cloud, what happens? The liquid drops comes on the face, right? Yes? So that is what? That is liquid in gas. Liquid in the air, right? Okay? So liquid in gas is what? Fog, mist, etc. Okay? Huh? This is a liquid in gas. And gas in gas, any gas can mix with any gas. Any gas can mix with any gas is the example of gas in gas. The air is an example of gas in gas solution. So you understood the classification of solution nicely? Clear? That concept, that pre-concept is there in your mind, hopefully that has gone now. Okay? The solution does not mean now anything liquid. Solution is the homogeneous mixture of two or more than two components. That's the homogeneous mixture of two or more than two components. If two components are there, we call it binary solution. If three components, ternary and so on. In our syllabus only binary is there. Two components in binary solution are called solute and solvent. What is solute? What is solvent? You know, the one which is more in amount is solvent. The one which is less in amount is solute. The solution will always take the state of solvent. Depending on the state of the solution, they can be classified in three types: solid solution, liquid solution, gaseous solution. Each of them can be further classified into three types. Yes, and we know the example of each. Yes. Now, any two substances, suppose you hold that sugar and water, if you add Sannavata I added just asked Amisha, দেখতে পাচ্ছি না. Amisha is not in the waiting room. না Amisha ইয়ে দেখতে পাচ্ছি না. একজন ঢুকেছিল, শোনো না, একজন ঢুকেছিল একটা অন্য একটা ফোনের নাম, ওকে আমি রিমুভ করে দিয়েছি, মানে ওর নিজের নাম লিখিনি। হ্যাঁ, ওকে নিজের নাম লিখে ঢুকতে বলো, আমি ওকে। So but okay, now suppose that the water we are taking water, little bit water, and in that we are adding little bit of sugar. Water and we are adding little bit of sugar. Fine, okay. Water and we are adding little bit of sugar to it. And if we stir it, it is going to produce the solution. It is going to produce the solution. There is no issue over this. Fine, okay. But if we take some water and add some add some sand and stir it, it is not going to produce the solution. Why? Why specific two components? If we add them, mix them, okay, they are forming the solution, whereas any other two components cannot form the solution. So what is the logic? What is the reason for the components to form the solution? There must be some reason for which some two components are forming solution, the other two are not forming solution. What is the reason? Okay, simple. See, there are two reasons, simply two reasons. One, suppose, just I am taking an example, then it will be easier for you. Whatever is coming in my mind, the example, don't think this I am remembering all these things. A little bit of water is there, and in that I added some amount of ink. I taught you in class 11 also, ink, some amount of ink. Clear? But when you add this ink, what will happen to this ink? It will all spread around first, then that will dissolve and will form the solution, right? Yes? What is happening to the entropy of the system? Entropy means what? Can you remember entropy means? Disorderness. Entropy means thermodynamics we studied in last year. Okay, entropy means disorderness, randomness. Okay? So when the ink was like this, was it random? Or when the ink sprayed all around, the thing was random? When the ink was in the form of a drop, was it random? Or when the ink just came in the water and sprayed all around, it was random or disordered? Which case it was disordered? Obviously second case. When it is drop means it is ordered in one position, it is staying. Now when we are mixing, it is all becoming disordered. More disorderness means more is the entropy. Okay? So that's the first condition for two components to form a solution. That the entropy of the system will increase. Entropy of the system has to increase to form a solution. Okay? Entropy of the system has to increase for formation of the solution. That's the first condition. Second condition. Okay? Same example, I am taking the ink one. When ink was alone, suppose this is A and the water is B. Okay? So in general we can talk about. When ink was alone, there was some interaction between its own molecules. Between the ink molecules only there was some interaction. That interaction is denoted by E, energy or energy of interaction between A and A. Clear? Between two A molecules. When B was alone, means only water was there, there was interaction between the water molecules. That is denoted by energy for B and B, right? But when we added this, one more new interaction generated along with these two. That is interaction between, all of you can understand this. This is interaction between A and B. Yes? If the interaction between A and B, if the interaction between A and B is greater than the average of the individual interaction, is greater than the average of the individual interaction. Okay? Average of individual interaction. That means EAA plus EBB divided by 2. That's the average of individual interaction. Then only they are going to form the solution. That's the second condition. So what are the two conditions for two components to form a solution? First, the entropy of the system should increase. Yes? Okay? And what is the second one? The interaction between the two components must be, energy of interaction between the two components must be greater than the average of the individual interaction. Average of the individual interaction. Is it clear or not? You tell me that first. This is the very basic concepts of solution. Very basic concept. Now we are going to move into a specific type of solution. Today we are going to do that. That is solution of liquid in solution of gas in liquid. Solution of gas in liquid. Okay? A specific one, solution of gas in liquid. That is the cold drinks and all in cold. Okay? The example is cold drinks and all. Gas in liquid. Tell me, now whenever we are opening the cold drinks bottle, what happens? All of us have experienced. What happens? The fizz comes out, right? What is coming out? Fizz coming out means what? What is coming out? You won't get it in the book, just close it, just close it. I will send you the study method. Yes? The carbon dioxide that was dissolved is coming out, right? The carbon dioxide that was dissolved in the gas is coming out. Why that is coming out? That was dissolved in the gas, why that is coming out? When you open the bottle, it is not coming out when the bottle is closed. Is it coming out? No, no. When you open the bottle, then only it comes out, right? Why? Pressure is released. When you open the bottle, the pressure is released. That means the carbon dioxide was there inside with a lot of pressure. With a lot of pressure, when you release the pressure, the carbon dioxide comes out. So can I say that if the pressure is more, the carbon dioxide in the solution is more, the gas in the solution is more, pressure देके उसको solution करके रखा था ना, जैसे pressure release किया और निकाल के आ रहा है, right? Yes or not? Very little is there. Did you understand that? This was observed by a scientist called Henry, and he proposed a law called Henry's law. Henry's law. What is this? It's very simple. When the bottle is closed, just try to understand. When the bottle is closed, okay, the Coke bottle or any cold drink bottle is closed. And another condition, when the bottle means bottle is open, the cap is open. Clear? Two conditions. Which is what condition, you tell me. I'm just drawing. These are gas molecules, obviously. Which is what condition? Tell me. The first diagram, that is left hand side diagram, is it in the closed condition or open condition? Closed condition? It is open condition. Yes, you understood that. Why? Because here the pressure is more, the gas is more. Yes, here the pressure is less, the gas is less. Pressure is released, so the gas is less, gas dissolved is less. So, can we say the bottle, the size, volume, everything is same, right? Okay? So, we can say the fraction of the gas, the mole fraction of the gas over here is more. Mole fraction of the gas over here is more. Okay? If the mole fraction of the gas is more in this case, the gas is exerting more pressure on the wall. That is why whenever we are opening this, it is coming out. In this case, it is exerting less pressure. He told that only. that the pressure that is applied by the gas in the solution, the pressure that is applied by the gas in the solution, obviously there is partial pressure, is directly proportional to mole fraction of the gas. जितना ज़्यादा mole fraction होगा गैस का उतना ज़्यादा partial pressure होगा. That is what he told simply. Okay? And hence P is equal to, he equated this, P is equal to some constant. Okay? Into X, proportionality constant. That proportionality constant he gave in his name and he wrote it as KH into X. But KH is called Henry's law constant. H is Henry. Okay? KH is called Henry's law constant. Okay? The online people, as this meeting is finished, you join with the same ID password. Okay? As this meeting is getting over 10, another 10 minutes is there, not now, another 10 minutes is there. As it is getting over, please join with the same ID password. Okay, so P is equal to KH into X. That's the mathematical form of it. Now we are going to see the graphical form of the Henry's law. Please understand the graphical form, because it's not only Henry's law. Whatever we are going to study the graphical form, you must understand it. The equation for straight line. Anybody has maths? You have maths. You? No? Anyone? Srija? No. Okay. But you must know this. Okay, these basic things you must know, and I want you to know it also. The equation for straight line is represented in general as y is equal to mx plus c. All of us know this, right? What is y? Y is the y coordinate or y axis. X is x coordinate. M is the slope and c is the intercept. The straight line can be of two types. See, whatever I am saying, please understand it, okay? Because I could have finished it by saying just one line, but I won't. Because it all will be required for you for the, next topics, next chapters even. Okay? So there are two types. Here y you are plotting, here x you are plotting. The graph straight line can be like this, where the value of x is increasing with the value of y, or the value of y is increasing with the value of x. Okay? Another way, the straight line curve can be like this. Means the value of y is decreasing with the value of x, or the value of y is also decreasing with the value of x. Clear? Okay? Fine. This type of straight lines having the slope value, slope means m. Slope is m. M is nothing but tan theta. Slope is nothing but tan theta. Okay? The slope is positive. This type of straight lines are called the straight lines having positive slope. The value of m is positive. Clear? And this type of straight lines will have slope. The value of slope as negative. These are negative slope straight lines. First point. Clear? Okay? What is C? Now if we extrapolate it, we call it extrapolation, not plotation. We call it extrapolation. Okay? Extrapolate it. It will cut the y-axis. Clear? Wherever it is cutting the y-axis, that is the intercept. That is the value of C. Yes? Okay? Same way here also, if we extrapolate, it will cut the y-axis here. This is the value of the intercept. Clear? By extrapolation, where it cuts the y-axis is the intercept of it. Clear? Now in this case, in this equation, we are going to plot. Please understand it. We are going to plot P, how P is varying. That is Henry's law, graphical representation. How P, that is partial pressure of the gas, is varying with the mole fraction of the gas. P is what? P is Y, right? P is Y. X is what? X is X. Yes? What is the value of M? KH, right? What is the value of M? We are just comparing it with this. KH is M. KH is obviously positive. So we are going to get a positive slope straight line. First of all. Clear? Okay? A positive slope straight line we are going to get. What is the value of the C? It's 0, right? Y is equal to mx plus c. C is how much? 0. Yes? Means where it is cutting the y-axis? 0. 0 means origin. Right? So we are going to get a straight line like this. Yes or not? We are going to get a positive slope straight line which is passing through the origin. This is what? This is the This is the straight line or the graphical representation of Henry's law. Now if somebody tells you to find out the value of kh from the slope, from the graph, straight line, what is slope? M is equal to tan theta, right? M is equal to tan theta. Slope is tan theta. Tan theta means what? Perpendicular by base. We know this, perpendicular by base. Now this graph, anywhere, this graph you take as a hypotenuse and draw any right angle triangle to it. This is a hypotenuse and draw a right angle triangle. Is it a right angle triangle? Taking this as hypotenuse, it will be. Anyone, you can draw this, anywhere. You can draw a small one also, doesn't matter. Anywhere. Okay, just taking this as hypotenuse, you draw a right angle triangle. This angle, obviously all these angles are the same only. This angle is theta. This angle is theta. Clear? Now we have to find out tan theta. So tan theta is equal to what? Perpendicular. This is perpendicular. Yes. Divided by base. This is base. Yes. We can count in the graph paper what is the division of perpendicular. Suppose 15 is the division of perpendicular. Suppose 15 divisions are there in the graph and 10 divisions are there in the base. So 15 by 10 is what? 15 by 10 is the slope. And that's the value of the kh. You can find out the value of kh. Graphical. Yes? Okay. Now, the value of kh does depend on temperature. The value of kh does depend on temperature. More the value of temperature, more the value of temperature, or more the temperature, more is the value of kh. kh for a particular solution of gas and liquid depends on temperature. More the temperature, more is the value of kh. Okay? If you could please join in another meeting. Now leave it and join in another meeting so that we can continue from here on. It's almost time. So I'm ending it. Join in another meeting. They will keep on joining. Let us start. The video is already done. So what we know, that's the value of kh depends on temperature. More the temperature, more is the value of kh. Now what we are going to study is actually the application of the Henry's law. There are three specific applications we are going to study. First of all, aquatic species. Aquatic species means fish and all. Okay. So fish, you know how they are, breathing. How are they breathing? They're taking the oxygen from where? From the oxygen that is dissolved in water, right? Okay, it is the oxygen that is dissolved in water. From there only they are taking the oxygen, right? Now, suppose some water is kept at lower temperature and the fish is there. If we heat it, just simple logic, you just tell simple logic, then I'll come to why. If we heat the water, will it feel comfortable? Will the fish feel comfortable or no? गर्म पानी में रहेगा मछली? नहीं ना? Okay, so it won't feel comfortable. Why it won't feel comfortable? Because the oxygen is decreasing. The dissolved oxygen in water is decreasing. How can we say that the dissolved oxygen in water is decreasing? Okay, see it over here. Now, at certain temperature, when the temperature is low, the value of KH is low. The value of KH is low, right? To maintain the value of P constant, P has to be constant, okay? Partial pressure has to be constant. To maintain the value of P constant, X will be more. At low temperature, please understand, at low temperature means temperature is less. To maintain the value of P constant, X has to be high. Yes or not? अगर KH कम होगा, तो X has to be more to make the value of P constant. Yes? So X is more. X is more means what? Mole fraction of the gas is more. Yes? That means oxygen dissolved in the water is more. When? When the temperature is less. Yes? But when the temperature is high, KH is more. KH is becoming more. To keep the value of P constant, what will happen to X? X will decrease. X decreases means the dissolved oxygen decreases and it will suffer in breathing. Breathing it will happen, it will suffer from the breathing problem. Yes or not? It cannot breathe because sufficient oxygen is not there. So can we come to the conclusion that aquatic species are more comfortable at cold water? Aquatic species are more comfortable in cold water. Why? Because more oxygen is dissolved in that. Yes? That is why the optimum temperature where the aquatic species is most comfortable is 4 degrees Celsius. You must know this, especially the biology students should know it. 4 degrees Celsius is the optimum temperature where the aquatic species is most comfortable. Why? Because at that particular temperature the dissolved oxygen is maximum. Okay? अगर 4 डिग्री से नीचे कर देंगे तो पानी ना बर्फ होना चालू हो जाता है. You know, the water starts turning into ice. Okay, so it obviously the fish cannot survive in ice, right? Okay, so that is obviously the dissolved oxygen. There will be no dissolved oxygen. That is why optimum temperature is 4 degrees Celsius. जितना temperature बढ़ाएंगे उतना dissolved oxygen will be lesser and lesser. Yes, and they will suffer more and more. Fine, that's the first of the. Obviously, which law is suggesting that we are just using the Henry's law only to sensitive that? That's the first application of Henry's law. The second application, I don't know how many, whether you have done it or not. If you haven't done, you must do it whenever you will get a chance. I myself has done for 2 times. So whenever you will get a chance, you will do this. Okay, but scuba diving, have you done it? Anybody? Scuba diving, you must do it. You must have seen that scuba diving. This is something really beautiful. Okay, whenever this underworld thing, the world under the water is something different, completely different, and it's really, really beautiful. I went 40 feet deep down the sea. So you know that now why I'm saying you that whenever you will get chance, obviously in India everywhere it is not there, 1 or 2 places it is there. In other countries it is there, Andaman is there. In Goa nowadays they have done in one place. Okay, this Andaman and Nicobar it is there. I had done in Andaman and Nicobar only. So you can do that whenever you go or you find countries also it is there. Anyway, so what they do, you know that. What is that? They carry a cylinder. And dive over there. Now that particular cylinder, if I ask you, I know that all of you will say that this is oxygen cylinder. This is not oxygen cylinder. First of all, this is not oxygen cylinder. Okay? Obviously oxygen is there. But along with oxygen, a huge amount of helium is mixed in that cylinder. Helium gas. Along with oxygen gas, a huge amount of helium gas is mixed. It's not the oxygen cylinder that is used in the hospital. Hospital में जो oxygen cylinder use होता है, that is only oxygen. But in this cylinder, where the scuba divers are taking, a lot of helium is mixed with the oxygen. Why a lot of helium is mixed? What is the reason? Okay, so it's very simple. When we are diving down, the pressure of the water on top of us is very high. As it is very high. As you are going down, the pressure of the water is very high. Now you are breathing that particular air which is present in the cylinder. You are breathing that. As you are breathing, what happens? The oxygen gets dissolved in your blood, right? Oxygen gas gets dissolved in your blood. Clear? Now, if you dissolve more oxygen, if the blood is getting more oxygen will be dissolved. Yes? If more oxygen dissolved in the blood, according to Henry's law, mole fraction of the oxygen will be more. If the mole fraction is more, pressure that will be exerted by the oxygen gas will be more. Yes? If the pressure is more, where is the blood? The blood is the vessels, blood vessels. It will experience a huge lot of pressure, along with the water pressure, a huge lot of pressure, so that the blood vessel can burst and the people can die. To avoid that, what is done? Oxygen is mixed with what? Oxygen is mixed with helium, which is the lightest gas. Yes? So, little bit of oxygen will be dissolved in your, the amount which is required for survival will be dissolved. Oxygen saturation becomes less when you come from scuba diving. That is why they don't allow you before checking your physical condition. They check your physical condition, then they give 45 minutes to 1 hour training, then only they allow us to go. Okay, it's not that anybody can go and anybody can dive over there. So that is oxygen saturation becomes very less, because very less oxygen is supplied to your blood. Otherwise, what will happen? If more oxygen is there, the blood vessel can burst. Okay, why? Because the mole fraction of the oxygen becomes more. So it is added with helium gas जो कि light है. उससे क्या हो रहा है हमारा? उससे ऑक्सीजन का प्रेशर जो है ब्लड वेसल में वो घटा रहा है. That is we are decreasing. Understood that? Which law is followed? Henry's law is followed. And that particular phenomenon, if it happens, भगवान करे किसी का भी ना हो, है ना? If it happens, then that particular phenomenon is called, that particular phenomenon of bursting the vessel is called bend. We call it bend. Okay? So what is bend? Bend is the phenomenon where the saturation of oxygen becomes more. Yes, the mole fraction of oxygen becomes more in the blood vessel, and because of very high pressure of water, as well as the pressure of what? As well as the pressure of the oxygen, the pressure of oxygen, the blood vessel can burst. Yes, that is what is known as bend. That is one application. The third application that is happening with mainly the soldiers, the soldiers or army people are posted in the high altitude zone, right? Like Ladakh or somewhere like Kashmir, they are posted over there not more than 2 to 3 months. They are posted maximum for 2 to 3 months, and then they are brought down. Why they are not posted for 2 to 3 months? More than 2 to 3 months? Because in that high level, the amount of oxygen level is very, very less. So whatever we are taking, the oxygen is not sufficient. The blood vessel has got, or the blood has got very less oxygen. The mole fraction of oxygen is very less. Okay? Because the pressure is less. Pressure is less, so mole fraction is less. P is directly proportional to X. Pressure is less, so mole fraction is less. Okay? Second Henry's law. And what happens if the oxygen saturation becomes less? Then the first thing that happens is that your the mental condition becomes a little bit of disbalance. Means you cannot remember everything. Sometimes you forget something. That happens when the oxygen saturation is less. Okay? This particular bimari, this particular disease is called, these two terms you must know. This particular disease is called anoxia. We call it anoxia. So the people who are doing the duty in the very high altitude zones are all suffering from anoxia when they are coming down. Okay? So they are treated properly, or they take the oxygen in time, okay, so that the oxygen saturation becomes more. So all these three are the application of what? Application of the Henry's law. So what is Henry's law? First, once again, just to recap it. What is Henry's law? Henry's law states that the partial pressure of the gas dissolved in liquid is directly proportional to the mole fraction of the gas. जितना ज़्यादा mole fraction है, उतना ज़्यादा हो. Yes? Okay. We know the mathematical expression for this. Yes, we know the graphical representation for this. Graphical representation of Henry's law. Now, how K varies with temperature we know. Clear? And the three applications. What are the three applications? First one is aquatic species, scuba divers, and anoxia. So, bent, anoxia, and aquatic species. These are the three applications, very commonly asked questions. Okay? Okay, आपका? So this is all about the gas in liquid. This is all about the gas in liquid. But before going further, I just missed out one thing. That is, missed out means what you should know it. We had discussed it in class 11, but once again I will discuss because that's also very important. That is concentration. Concentration of solution. Concentration of solution. What do you understand by concentration of solution? Understand by concentration of solution. Tell me. What do you understand by concentration of solution? बताओ. Concentration बोलने से समझते क्या हो आप? I am not asking anything कि क्या है, क्या unit नहीं. I am just asking what do you understand by concentration? दो solution दिया गया है, एक का concentration ज़्यादा है, एक का concentration कम है. What do you understand by it? What is your, thinking about concentration? नहीं, वो सब नहीं. I am not asking all these details. I am simply asking that what do you understand? Understand by concentration. Suppose if two glasses of water of same size you have taken. In one I had added 1 teaspoon of sugar. This all you know. Already I taught you. In another I had added 2 teaspoons of sugar. Okay, which is more concentrated? Why? Why? No. More amount of sugar is added. See. These are the things which should go out from your mind. You should, whatever you are saying, you should tell it after thinking on it. Now I have taken a bucket of water. In that I had added 5 teaspoons of sugar. I had added more sugar in that. You told more sugar, right? I added more sugar. Now which is more concentrated? Second one still. So there now less sugar is there. Nana? Yes or not? So is it because of more sugar? No. So why? Why it is more concentrated? बताओ. Why are you saying that this is more concentrated? कैसे पता चलेगा ये more concentrated? कैसे पता चलेगा? Suppose you don't know how much sugar I have added. I have given you 3 solutions. 3 solutions of sugar and water. How can you say me that which is more concentrated? You don't know how much sugar I added. देखने में तो एक ही लगेगा ना तीनों. Yes, थोड़ा थोड़ा करके दे दिया. ठीक है? Now how can you tell me that which is more concentrated? Test करो. Test करो. कि हम test करें. Yes, that's the correct answer. You have to test it. I am not asking anything of IIT level or you thinking something which I am no, nothing like that. Science is not that. If you know the basic thing, you know everything. Test code. How you know? Test code. How you know? Tell me. Which is more concentrated? Which is more sweet? Most sweet, right? Okay. That is called strength. That is called strength. How strong the solution is. How strong the solution is, right? More the strength of the solution, more is the concentration. Yes? Yes or not? So concentration is nothing but strength of the solution. It's nothing but the strength of the solution. That's the concept. That's the concept. कैसे हो रहा है वो तो अलग बात. You know, you told more sugar. Now I told more sugar नहीं है. So it is not only depending on sugar. It is also depending on water. Yes, that means it is depending on both solute and solvent. More solute, more is the concentration. More solvent, less is the concentration. Yes? Now that all you know, there is nothing new for you. Okay? Now concentrations can be expressed in different units, we should know these units. The first one is molarity. You know it already. Molarity. Who will tell me what is molarity? That is denoted by capital M. What is molarity? Number of moles of solute in 1 liter of solution. 1 liter of solution. Total volume of the solution 1 liter. Whatever number of moles is present in the solution is called the molarity. So mathematically, we can write this. Know this. You have to know this. Okay. And as I told, I will send you the study maps today in WhatsApp group also, so that most of them are not coming on this. So you will get the soft copy. The hard copy will be ready over here by tomorrow or day after tomorrow. So whenever you will come, you just collect it from ma'am. Okay, the hard copy. Because don't read from soft copy. That is not a very good idea. It's not done. That is the hard copy. So you take your hard copy to the sorry also. Okay, so that is number of moles of solute, yes, divided by volume of solution in liter, right? Yes. Now in solution chapter, let me tell you that solutes we are going to represent by suffix to, solute, and solvent we are going to represent by suffix 1. Anything of solvent we are going to represent by suffix 1, and anything of solute we are going to represent by suffix 2, because solvent is more in amount, so that is number 1, solute is less in amount, so that is number 2. So this one mathematically we can write, see molarity, mathematically we can write equal to number of moles of solute. You just write it with me, along with me, okay? This one at least. Number of moles of solute, can I write it as N2? N is number of moles. Solute 2. So N2 is what? Number of moles of solute. Yes? Divided by volume of solution in liter. Volume of solution means total volume. Right? Volume of solution means total volume. And total volume is nothing but it is represented by V. Obviously in liter. Okay? So number of moles of solute. Number of moles is what? We have studied the mole concept. Number of moles is nothing but mass of the substance divided by molar mass. Mass of the substance or weight of the substance divided by molar mass, which we represent by W2 divided by M2. In place of N2 we can write W2 by M2. What is W2? What is W2? Mass of solute. 2 means what? Mass of solute, weight of solute. W is what? Weight, okay? Weight of solute. Clear? In gram. In gram. Why in gram? Because molar mass must be in gram. Molar mass is in gram, so it also has to be in gram. Yes? Divided by V. This is the mathematical expression for what? This is the mathematical expression for molarity. Yes? Next unit is molality. Next unit is molality. Molarity is expressed by small m. Molarity is expressed by small m. Okay? What is molarity? It's nothing but number of moles of solute. Number of moles of solute dissolved in 1 kg of solvent. Dissolved in 1 kg of solvent. That is mass of solvent. Mass of solvent in kg. 1 kg of solvent means mass of solvent in kg. Yes? Okay? Let us write it mathematically. Number of moles of solute N2. Yes? Yes? Okay? Mass of solvent W1, but that's in gram. Mass of solvent is W1, that's in gram. When we express it in kg, it is W1 by 1000. Yes? Did you understand that? Yes or not? Yes? Now what is N2? N2 is nothing but W2 by M2. N2 is nothing but W2 by M2 divided by W1 divided by 1000. Yes? Yes? So that is equal, if you just simplify it, it will be 1000 W2 and 1000 ऊपर चला जाएगा. W1 into M2. That is molarity. Did you get it? Yes or not? Okay? Fine. The third one is mole fraction. is mole fraction. Mole fraction of solute. Mole fraction is represented by X. Solute. Solute is 2. So mole fraction of solute is X2. Right? Fraction is what? Fraction of boils here. 1 by 3. Right? Anna? 1 by 3. Yes? So what is fraction? That amount divided by total amount. Mole fraction. Number of moles of solute divided by total number of moles. So that is equal to what? That is equal to, can I write it, N2 divided by N1 plus N2. Total is what? N1 plus N2. That is X2. Yes, simple, you know it already. That mole fraction only we were talking till now. Yes? Then mole fraction of solvent. Mole fraction of solvent, that is represented by X1. Yes? X2 is solute, X1 is solvent. What is mole fraction of solvent, you tell me? N1, number of moles of solvent divided by total number of moles, that is N1 plus N2. Yes? Now fraction of boys is 1 by 3, fraction of girls is 2 by 3. The total will be always equal to 1. The total of all the components will be always equal to 1. Fraction का total हमेशा 1 होता है, right? So can I write x1 plus x2 should be equal to 1? Yes? So x1 equal to 1 minus x2. That is mole fraction. That is 1 unit. Yes? The next unit is mass to mass percentage. Also that also you know, mass to mass percent. Mass to mass percent. We write it like this, W by W percent. We represent it like this, mass to mass percent. Means out of 100 gram of solution, how much gram of solute is there? Okay, so that is, how do we represent it? W2, mass of solute, by total mass of solution. Total mass of solution is what? W1 plus W2 into 100. Yes, that is mass to mass percentage. Understood that? In certain cases, the concentration term is expressed up to here only it is there in your syllabus. In your syllabus means board, but remaining two I am saying is maybe sometimes comes in the competitives, so you must know this also. Okay. Next is volume to volume percentage. In some medicine thing, you can see it's written V by V percentage. In some medicine bottles now, you can see V by V percentage. So same thing only. V by V percentage is what? Volume of solute divided by total volume, okay, into 100. Volume to volume percentage. Yes? Okay, when it is used, it is mainly used when two liquids are mixed. When two liquids are mixed, दोनों का volume लेके हम लोग mix करते हैं. Okay, this medicine and all when they are preparing, they are using this term. Another one is that weight to volume percentage. Weight to volume percentage. You can very easily understand what is weight to volume percentage. So that is equal to weight of solute, and divided by total volume. What is total volume? V1 plus V2, okay, into 100. Yes? Yes? Okay? Done? There is one more unit which is used for some specific solution. Specific solution means very, very dilute solution. Means the amount of solute is very, very less. Certain cases. For example, mineral water. In mineral water, there is iron, there is sodium, there is potassium, there is magnesium. But what is the amount? It's very, very less. Okay? Now, if we express the concentration of that iron in mineral water by any one of these units, the value will be very small. It will be 0.0000 something. Means it will be almost equal to 0. So it is a very dilute solution. So to express the concentration of the dilute solution, we use another unit of concentration, and that unit is called ppm, parts per million. So first point about parts per million you know is that this particular unit is used to represent the concentration of very dilute solution. Why? Because for those solution, if we represent the concentration by any other unit, the value will be very less. Clear? Now what is parts per million? Part and fraction, there is no difference. The same thing, part and fraction is same. So it was percent. Mass to mass percent was there, right? Percent, cent means 100. Okay? And it is per million. Part per million. So W2 divided by W bar n plus W2. That is part. Mass of solute divided by total mass is the part. Per million. Million means 10 to the power 6. Million means 10 to the power 6. Percent it was 10 to the power 2, that is 100. Per million means it is 10 to the power 6. Is it clear? So these are the different units for what? These are the different units for concentration by which we represent the concentration. Yes? Now, next we are going to move, at least little bit we are going to know about this today itself only. Next we are going to move with the solution of solid in liquid. Solid in liquid. Next one. Gas in liquid we have done. Now solid in liquid. But today I will talk about one type of solid. There are two types of solid in liquid. Solid in liquid. Now tell me which is solute, which is solvent. In solid in liquid, solid is solute or liquid is solid? What is solute? Solid is solute and the liquid is solvent. Okay? So the solution will be in the form of liquid. Clear? Okay, so that's it. But this solute, this solid solute can be of two types. Can be of two types. Today we will discuss about one type one. One we call non-volatile solute. Non-volatile solute means this won't volatile, this won't convert into gas. This won't convert into gas. This won't convert into vapor. Clear? For example, sugar, salt. This is not going to convert into gas if we convert the solution. Another one is volatile solute. Another one is volatile solute. There are certain solutes. If we dissolve that, that will also convert into gas. Okay, that is volatile solute. So obviously today we are not going to talk about this, we are going to talk about this today. But before going to further detail, we must know one term first. Okay? And that is vapor pressure. That is vapor pressure. What is vapor pressure? Obviously vapor pressure of a liquid. What is vapor pressure? Okay? Before going to vapor pressure, you must tell me what is evaporation. Tell me what is evaporation. You have heard about this from lower classes only. Tell me what is evaporation. Evaporation क्या है बताओ. बताओ मुझे. What is evaporation? Suppose we have taken a certain amount of liquid in a glass with a covered container. Okay? Some water molecules are there. Suppose only water molecules are there. Please understand it. Water molecules are there. Now I have drawn the water molecules like this. The water molecules present in the container can be classified in two types. The first type which are present in the surface. These ones. Okay? These are called the surface molecules. And the one which is present over here. Okay? Which is called the bulk molecule. Bulk molecule. Surface molecule and bulk molecule. Obviously they have the difference in properties. Why they have the difference in properties? Because the surface molecules are attracted only downward. इसके नीचे सिर्फ molecules है. और bulk molecule क्या होता है? It is attracted from every side. Yes? So there is some difference in properties. Okay? Now what is evaporation? You know the difference between evaporation and boiling. Evaporation means what? The conversion of liquid into vapor. Boiling is also conversion of liquid into vapor. But what is the difference? Evaporation happens from the surface. The surface molecules converts into gas. Then the next surface exposed, next surface is converted into gas, and so on. And it can happen at any temperature. If you keep some water today here, tomorrow will come and you will see no, there is no water. Because evaporation takes place. But if you keep some more water, you will see the lesser amount of water is there, but still some water is there. Means it started, but it did not end. Yes? Okay? But what is boiling? Boiling means the whole water molecules. The molecules in the surface as well as the molecule in the bulk at a time are converted into the vapor. And it is happening at a particular temperature. Yes? As you know, water normally boils at 100 degrees Celsius. But water evaporates at any temperature. Yes? We are talking of evaporation here. If I keep some water over here, please tell me, just two things I will ask today. But that's much only, just two things. I am not going to go further, no mathematical detail, nothing. Just the concept I will give today so that next day we can do the further. Just tell me, just pure water I have taken, just water I have taken. The surface molecules are there and they are getting evaporated. So certain molecules is getting vaporized and obviously it is covered. It is covered. Okay. Certain molecules are getting vaporized. This process will continue till the equilibrium is reached. एक equilibrium आएगा, evaporation बंद हो जाएगा, evaporation बंद हो जाएगा क्योंकि ये covered है. अगर open होता था तो equilibrium आने में बहुत देर होता था, right? और almost last में आता था. Now these molecules, please understand it. These molecules which is evaporated and staying at the top level, I mean top of the surface, is exerting some pressure. These molecules are exerting some pressure. Yes, this pressure is called the vapor pressure. This is called the vapor pressure. So what is vapor pressure? When a liquid, okay, is kept in a container with a covered, in a covered vessel, clear, the evaporation will take place. Till when? Till the equilibrium is reached. Okay? And the vapor molecules which is evaporated will exert certain amount of pressure. This pressure is known as vapor pressure. Yes? Now tell me, if I increase the temperature, what will happen to the evaporation? Simple question. If I heat it, what will happen? More vapor will be produced. More vapor molecules will be produced. So pressure will be more. Vapor pressure will increase. So the increasing temperature, the vapor pressure is increasing. Very good. So I am drawing the vapor pressure curve. Vapor pressure curve, we call it vapor pressure curve. Clear? Here we are plotting vapor pressure in this direction, and in this direction we are plotting temperature. At this temperature, this is the vapor pressure. If we increase the temperature, the vapor pressure will increase. But it is not going to increase uniformly. It is going to increase like this. This is the vapor pressure curve. This curve I have drawn for water, suppose, that is pure solvent, only for solvent molecules. Clear? Only for solvent molecule. Clear? Now tell me, in this container, same amount of water is there, and I have added some sugar to it, some non-volatile solute to it. It can be sugar, it can be salt, anything. Okay? What will happen to the vapor pressure? Think that. Water molecule is there, in that I had added some sugar, the solution is made. Okay? What will happen to the vapor pressure? I am just giving you the hint. These are sugar molecules. What will happen? Less evaporation will take place. Yes? Why less evaporation will take place? Because at the surface, the number of molecules that is to be evaporated is less now. Because the solute is non-volatile, that cannot evaporate. Understood that? So what will happen to the vapor pressure under the same condition? The vapor pressure will decrease. Right? So if we measure the vapor pressure of the solution, at this temperature the vapor pressure will be less. Yes? The vapor pressure of the pure solvent was this much. The vapor pressure of the solution of non-volatile solute will be this much. It will be less. Did you understand that? Yes? Now if I heat it, its vapor pressure will also increase. Clear? But at every time it will increase. But at every time that will be less than that of the pure solvent. because surface में हमेशा the non-volatile solute का molecules होगा. So this curve is the vapor pressure curve for what? This curve is the vapor pressure curve for the solution. Did you understand what is vapor pressure? You understood that what is vapor pressure? Yes. How the vapor pressure is varying with temperature? Did you understand that? Yes. Okay. And what is happening to the vapor pressure of the solution of non-volatile solute? The vapor pressure is lowered. Whatever was the vapor pressure of the pure solvent, as we add the solute, non-volatile solute, the vapor pressure is lowered. This particular phenomenon is called lowering of vapor pressure, which will start next day. Okay, lowering of vapor pressure for the non-volatile solute. Is it clear? Okay. Yes.